Hey there and welcome back. So today I wanted to talk to you about this, L'Hopital's rule. In a previous video I showed you how to take a rational expression that when you tried to do direct substitution resulted in an indeterminate form of 0 over 0. But there's another thing that we can do, and that thing is called L'Hopital's rule. So what it says is that if the numerator and denominator are both differentiable over an open interval, we can just take the derivative of the top and the bottom and evaluate it that way. So let's see, this is differentiable, this is differentiable. It's not going to be differentiable at 3 naturally, because 3 minus 3 gives us a 0, and in the numerator I end up with a 0, 9 minus 6 minus 3. So let's go ahead and try this L'Hopital's rule. So here's how it will show up in your assignments. You end up rewriting this part. This is every student's favorite. The limit as x approaches 3 of the derivative of x squared minus 2x and minus 3 in this case over the derivative of x minus 3. So far so good. So that's all we have done is taken the derivative of the top and the derivative of the bottom. But let's do that. So the limit as x approaches 3 of, let's see, what's the derivative of x squared minus 2x minus 3? Well, that's just 2x minus 2. And in the denominator, the derivative of x minus 3 is just 1. So 1. Forgot my target. So now if I substitute into this, if I do direct substitution, I end up with 2 times 3 minus 2, or 4. So the final answer, the limit of this expression as x approaches 3 is 4. And you can check that by using what I showed previously, the dividing out rule, right? I could divide out that x minus 3 and I'd still come up with a 4. Just for good measure, let's do that. Let's do, let's see, x minus 3 times x plus 1 all over x minus 3. So this is what I showed in a previous video. This is called the dividing out technique. And when I go to direct substitution there, if I substitute this 3 in place of this x, I still end up with 4. So that's just another way to do it. When you end up with an indeterminate form, you can use L'Hopital's rule. So let me show you a couple of other ones, because it also works with transcendental functions. So let's look at some trig functions next. All right, so here's one that has a trig function. Let's use this L'Hopital's rule. So the numerator and denominator are both differentiable on an open interval where x goes to 0. So let's go ahead and look at that as a, I'm writing now to be a little faster. So let's look at the derivative up top, the derivative of the sine of 5x, because what happens, let's double check this, I shouldn't have skipped this, but as x goes to 0, you have the sine of 0 over the sine of 0, which yields an indeterminate form. So we don't know what to do with it. So we can't do a dividing out technique like we did before, but now we have this L'Hopital's rule. So let's just take the derivative of both the top and the bottom, and we'll see what happens here. So the limit as x approaches 0. Let's see, derivative of the sine of 5x would be the cosine of 5x. Remember, I have to use the chain rule here. So times the derivative of the angle here all over the derivative of the sine of 2x would be the cosine of 2x times the derivative of 2x, so that's a 2 here. Now when I go to evaluate this, what happens is cosine of 5x, let's see, if x is 0, we have the cosine of 0, which is 1. And in the denominator, you have 2. Can we see that? 2 times the cosine of 0, which is 1. So 2 times 1 in the denominator ends up giving us 5/2, or 2.5. So that would be our final answer for this one. So here's another, this is one that I could not have used a dividing out technique, so I have to use something like L'Hopital's rule if I want to simplify it. Let me show you one more example, but if you're getting value from this, go ahead, please hit the like button. All right, here's the third example that I've selected. Notice that if I tried to evaluate this as x went to infinity, well, as x goes to infinity, the natural log is going to go to infinity, and x squared goes to infinity, that's going to go to infinity. So I end up with like an infinity over infinity, which is another form of our indeterminate, that's another indeterminate form. So let's see if we can't use L'Hopital's rule, because I'm differentiable in the top and differentiable in the bottom. So let's go ahead, and in the first step, I'll just write down that I'm taking the derivative as x goes to infinity of, let's see, natural log of x over the natural, or I'm sorry, over the derivative of x squared. All right, so in our next step, we will take the derivative. So x goes to infinity, and the derivative of the natural log of x is 1 over x. And the derivative of x squared is 2x. So now let me simplify this a little bit for us. So that would be 1 over 2x squared. So the limit as x goes to infinity of 1 over 2x squared, right? Reciprocate, multiply, so it's 1 times 1 in the top and x times 2x in the bottom. So I have this limit as this is going to infinity. Now, can we see that? Now I can make a substitution that says, hey, this is going to get bigger and bigger and bigger, this denominator. And what happens when my denominator gets bigger and I have a constant in the top is that this just goes to 0. The whole thing simplifies to 0. So hopefully, make that a little bit darker. Hopefully we can see that. I should have worn a black shirt. In any event, there's 3 examples for you using something new called L'Hopital's rule, and we use it when we're presented with this indefinite form, whether it's 0 over 0, infinity over infinity. I'll make another video that shows infinity minus infinity, but it basically says you can take the derivative of the top and the derivative of the bottom if it's differentiable on an interval that includes c. And so I hope you liked L'Hopital's rule. Depending on where you're taking calculus, you may not get that till Calc 2. If you're taking Calculus 1 for engineering majors, you'll probably do it in Calc 1. But in any event, here we go, L'Hopital's rule. If you like this kind of content, please go ahead and subscribe and also hit the like button, give me a thumbs up. I hope everything's going great with your school year so far, and I will see you the next time.